So, we have talked about ways we can display our data. And we all had our mind blown with the stem and leaf plot yesterday. Finally learned something new. So, we are talking about a couple other things that probably are totally new on this. In order to talk about the frequency polygon, we need to understand what a class midpoint is. So, it's the sum of consecutive lower class limits divided by 2. What I mean by that, let's say we saw yesterday some classes for the first time, right, when we grouped our data. So let's just say whatever it might be. We had classes of 15 to 17.9, 18 to 20.9, 1 to 23.9, and so forth. Alright, so let's pretend those were my classes. What is the class width? Remember from yesterday, the class width is how far from the beginning of one class to the beginning of the next. How far is it from 15 to 18? Okay, so my class width is 3. Okay, if I want the midpoint of this class, it's the middle, so it's like an average. But you actually take the beginning of one to the beginning of the next. So we need the average of those. Okay, so you can grab a calculator if you need to, but to find it, I'm going to do 15 plus 18 and divide it by 2 to find the middle of those two numbers. And what does that get me?
16.5.
So that midpoint is 16.5. All right, so what would this one be from 18 to 21? We do 18 plus 21 divided by 2. All right, from 21 to 24. How'd you get it so much faster that time? Okay, my class width is 3, right? So to get from one class to the next, I go up by 3 every time. So to get from one midpoint to the next, I'm just going up by 3. So the next one would be, okay. So we see that sometimes, you might see it like on a histogram. Instead of marking where the beginning of one rectangle is and where the end is, it might just have the number in between. So it might say 16.5 and have your rectangle for your frequency. And that's showing you the midpoint. So you have to have an understanding of the class width to know what classes are represented by that. One type of graph we might see with these is called a frequency polygon. So it's kind of like a line graph. So basically you have a point and you connect all the points with a line. The thing is though, the points on the x-axis are the class midpoints, and they are always connected to the horizontal axis. So it will always connect back to the x-axis at the beginning and end. So I put in a picture of one on the next slide for us to talk about. So this was, maybe it was our Old Faithful example I think we had yesterday. We had some of this data. So this is time between eruptions in seconds. The midpoints, we can see this one starts at 670, the next one starts at 680. So the middle of those is 675. So when you come over here, 675 is right here, and that has a frequency of 2. Okay, 680 and 690 is 685, that's 0. 695 had my 7. 7:05 had my 9. 7:15 had 9. 7:25. So the points on the X are the midpoints. What's weird about these is the first and last point. Do I have anything with a 665 midpoint? No. Do we have, I didn't even label that one, a 740 midpoint? No. But that's part of a frequency polygon. It always connects back at 0. So when you're looking at one of these graphs, the first and last points don't really exist. They're just made up to connect it back to 0. Your actual data are the points in between. So I wanted to look at one of these and try to answer some questions about it. See, last year we had to make those, but now they just want you to understand them. So good for us, we don't have to make them. All right, what is the class width? So this one is GPA, your cumulative grade point average. Class width is how far from the beginning of one class to the beginning of the next. Now, when I looked at, like the example I made up, okay, this class width was 3. Could I have also found it from the distance between my midpoints? Yes. So I don't have to have the original numbers. I can look, these are my midpoints here, but how far is it to get from 0.75 to 1.2? Good. All right, how many classes are represented? Keep in mind, are the first and last point real? No, they were made up just to connect it. So we only have 1, 2, 3, 4, 5, 6 real points. So there are 6 true classes here. First and last points we just ignore. All right, this is where we have to think for a little bit. The lower and upper limits of the first class. Okay, we know the first real class is right here, right? That was my midpoint. So I know the midpoint of the first class was 1.25. But I also want to know, where did it start and stop? So to find that, we could think, okay? We know the midpoint. What would my class have been? We really just need to find this first number. And it's going to be in between the two midpoints. What's in between 0.75 and 1.25? 1. And we know the class width is how much? 0.5. So that means the next class has to start at 1.5. The first class then has to end before we get to 1.5. So when would it end? 1.49. Why did we choose 2 decimal places? 2 decimal places in the problem. So my first class is from 1 to 1.49. Lower in the limit just means a smaller number, the beginning number. Upper is the ending number. And we can see, is 1.25 in the middle of those? Yeah. All right, what are the lower and upper limits of the class with 25 students? So where do we have 25 students? 2.75. Okay. So it starts right here in the middle. What's in between 2.25 and 2.75? All right, I know my class width is 0.5, so the next one starts at 3. So this has to end before 3.
2.9.
Right, so that can be hard, looking at the midpoints and trying to figure out the classes to start with. You're really just thinking the middle of 2 things, average them. Do you guys have questions over that? So a couple other things that we might see. Cumulative frequency distribution displays the total number less than or equal to, so like how many to this point. And we can do the same thing with relative frequency. So it makes more sense if I just show you a table. All right, this is the one we were just looking at. Our time and how many in each. Okay, so the cumulative frequency, here I have 2. If I don't add any more to it, at the end of the next one I still have 2. If I have 7 new ones, then now I have 9. So it's just how many up to that point. So you're adding your new occurrences plus what you had before. So when we get to the end, I can quickly see, oh, there were 45 observations here. Relative frequencies, we know you just divide your frequency divided by your total. And so if you're doing your cumulative, it should always end at 1, because that should be everything up to that point. So cumulative just means add all the ones up to that point. You might see those in a graph. It's called an ogive. We won't really use it in here, but it's just graphing like that line graph with all those points cumulative to it. The final thing we might see, time series data, that's really just your line graph when we're looking at different points in time. So unlike frequency polygon, it doesn't connect back to 0. We don't have to do midpoint. You're just straight plotting your points and drawing a line between them. So if I look at this one, this data shows the closing price of the Dow Jones from 1990 to 2007. And so my year, 1990, is on my x-axis. My value is on my y. And you just connect them with a line. In what year was the closing the lowest?
1991. Yeah.
Like our lowest, so 1991. Between what years was there no change? So when was this thing just constant? It's kind of hard to tell for sure, isn't it? It looks like maybe between 98 and 99.
2004, 2005. Yeah, I think 04, 05.
And
Close.
Yes,
we look
2005.
2004 and 2005. So those are both pretty close. Which ones? It might be easier to see on a paper, or you can, hold a ruler between them. Approximately both of those. I think 2004 and 2005 is probably a little bit flatter, but this one's pretty darn close too. All right. Any questions? So, I'm done. Oh, yes.
Are all these chapters going to be in a packet like this?
No. Do you like the packet?
Yeah. Never everything's a lot more.
I'll consider it.